Good morning, everyone. I'm going to spend a few minutes talking about a common experiment one and providing an update on where we are. So common experiment one is all about understanding how cover crops affect nitrogen cycling and nitrogen management. Next slide, please. All right, so nitrogen fertilizer in agriculture is kind of a double-edged sword in that it's a critical nutrient that we need, but also has some pollution problems. So on the positive side, it's allowed us to simplify our production systems, which has made it so we can grow really, productive crops more frequently in the rotation, increase the yield, decrease the amount of natural lands that we have to bring into agriculture. But on the negative side, those simplified systems have led to environmental problems from erosion to herbicide resistance, and our use of nitrogen fertilizer in agriculture has led to water pollution, hypoxic zones, and contributed to production of N2O, which is a greenhouse gas. So we have some negatives that we need to address related to nitrogen. Next slide, please. And so cover crops can be one tool that we can use to try to reduce some of the negative impacts of nitrogen in our cropping systems, making those simple production systems a little bit more diverse, filling in the gap where we don't have plants growing can help to reduce the water pollution caused by nitrogen and potentially the greenhouse gas production as well. Next slide, please. So we understand a few aspects of cover crops and nitrogen pretty well. We know that having that cover crop present during a time when the land would otherwise be bare can be really impactful in terms of reducing nitrate leaching. And also by having that cover crop to take up that reactive nitrogen and then build biomass, it's taking nitrogen that could have been lost in the system and turning it into organic matter that can increase the soil productivity over time. On the other hand, there's still some uncertainty about how nitrogen fertilizer management should be adjusted in systems that include a cover crop. Especially in the case of our grass cover crops, we know that they're helping to retain nitrogen in the system, but that nitrogen may not be available at a time when the cash crop needs it. So there may be some tendency to want to apply some additional nitrogen or maybe adjust the timing of that nitrogen fertilizer. But that's an area that we still need to learn more about. And also on the legume side, how much of a nitrogen credit can we count on from the legume cover crops? And then second uncertainty relates to the precision agriculture side of our network and our goals, that there's some uncertainty about how a cover crop could affect the precision with which we deliver nitrogen fertilizer, relying on cover crops to release nitrogen maybe introduces a little uncertainty because the organic matter needs to mineralize, and that can be impacted by the weather. So maybe some concern about being able to precisely deliver nitrogen when we're in a cover crop system. Next slide, please. So this project, our common experiment one, is kind of looking at the optimum nitrogen rate, how it's impacted by cover crops, and the variability in that, and how that variability is impacted by cover crops. And so that economic optimum nitrogen rate is driven by the yield response of the crop to nitrogen fertilizer inputs, and also the price of the crop and the nitrogen fertilizer. But that yield response is really impacted by three different major factors. So we have the nitrogen being supplied by the soil or the cover crop residue. We have the demand of the crop, which kind of relates to the yield potential. How much demand do we have for nitrogen from that crop? And then finally, the nitrogen losses, how much of the nitrogen that we add will be used versus lost to the environment. Next slide, please. So these three, previous slide, please. Thank you. These three factors are impacted by things like weather and soil type, but also I've highlighted here some of the major processes that could be impacted by cover crops, because a cover crop can impact how much nitrogen is mineralized or possibly immobilized, how that cover crop is demanding nitrogen. For example, if the cover crop impacts soil moisture in a positive way, that could increase the crop demand for nitrogen. And then, the cover crops also impact things like nitrate leaching and other nitrogen loss pathways. Next slide, please. So with all these different factors involved in determining that optimum nitrogen rate and how they're impacted by things that are unpredictable, like the weather, it can be very hard to predict the optimum nitrogen rate, and it creates a lot of uncertainty about how much nitrogen to apply. So this is just an example of different yield response curves in the same field over different years, and how that optimum N rate varied from 125 to over 200 pounds per acre. And so this uncertainty, it makes our ability to deliver nitrogen, it just makes it hard to be precise with how we deliver nitrogen. And oftentimes, I think farmers may want to avoid having a year where, the crop would be really productive if they had just applied enough nitrogen. So that uncertainty may create a situation where farmers apply a little bit of extra just to make sure they're not under applying. And so when we think about cover crop effects, we want to think about not only how does it affect the average optimum nitrogen rate, but also how does a cover crop affect our certainty in that economic optimum nitrogen rate. If we have more certainty in how much nitrogen is needed, then we may be able to be more precise and not have to apply a little bit of extra. Next slide, please. So the primary questions of Common Experiment 1 surround cover crop biomass production, nitrogen uptake, and biological nitrogen fixation, and what environmental factors help to predict those variables. Secondly, how does the legume grass and legume grass bicultures impact optimum nitrogen fertilizer rate for corn and cotton? And then finally, related to that variability, not only how do the cover crops impact the average optimum N rate, but how do they affect variability in the optimum N rate among different locations and years? Next slide, please. And then we also have some things that the team has discussed as questions that are of interest that weren't part of our primary goals, but many of the members and the locations have decided to opt into these additional questions. So one is using a litter bag study, how much nitrogen do cover crops release during cash crop growth, and how can we better predict those nitrogen release patterns based on environmental variables. How do cover crops impact soil moisture in the subsequent cash crop? How do cover crops impact the response of the cash crop to sulfur? Next slide. So there are 15 locations in Common Experiment 1, and they span all the way north to Vermont and all the way south to Florida, and then as far west as Nebraska. Next slide, please. So the overall design is those 15 locations. We'll be conducting the study for 3 years, and we'll rotate to different fields each year. We have our main factor is the cover crop treatment, so that's cereal rye, a legume cover crop, hairy vetch, or crimson clover, a mixed cover crop, and then no cover. And then within those main plots, we have different nitrogen fertilizer rates that help us characterize that yield response to nitrogen fertilizer in our different cover crop treatments. And then each location will have 4 replicates. Next slide, please. And then in terms of our metrics, we plan to fully characterize the soils at each location. Basic weather data collection. We'll have soil inorganic N sampled in the fall and also in the spring. We'll sample for cover crop biomass, the composition of the mixture, overall nitrogen uptake, as well as how much is coming through biological fixation, and also quality attributes like lignin, cellulose, and hemicellulose. We'll be looking at the litter decomposition using the litter bag approach, measuring the nitrogen uptake of the cash crop, as well as the yield and population of the cash crop. Next slide, please. So right now we're in the planning stages. We've been having our monthly calls and working out our protocols. We're planning to start our year 1 study this fall. That'll go for a year, and then we'll repeat the study and then repeat it again for those 3 years. And then after that, we'll be working on data analysis and writing. But we've been making good progress on the planning, and I want to say thank you to the Common Experiment 1 team for being very engaged and participating in the calls and sharing your ideas. If just for reference, we meet on the last Wednesday of each month at 11 Eastern Time if you'd ever like to join our call. And I included there our Google group email address.